Okay, so to continue on with 3.5, so there's one more problem that has two equations with two variables. So just like we were doing at the end of class last time. So you have on number 4, you have 3x plus 2y equals 34. And you've got 2x plus 3y equals 36. We want to solve for x and for y. Now, before this, the problems that we had, if we added them together, one of the variables canceled. But if I add these together, nothing's canceling. Okay, but remember the rule of equations says I can do anything to one side as long as I do the same thing to the other side. So, and it doesn't matter who you cancel, your x's or your y's. If I'm going to cancel my x's, I'm actually going to have to, because I can't multiply 2 by a good whole number and make it 3. Okay, so I'm going to have to mess with both equations. Okay, so you say to yourself, what is the first number that 3 and 2 will both go into evenly, which would be 6, which means you want them to be opposite 6s. Doesn't matter who's positive 6, it doesn't matter who's negative 6. You just have to have one of each so that when you add them, they'll cancel. So if I make this top one by positive 6, I need to multiply this 3 times 2. So I'll multiply that whole equation times 2, which will give me 2 times 3 gives me 6x plus 2 times 2 gives me 4y equals 2 times 34, which gives me 68. So if I made this one the positive 6x, it means this x needs to be negative 6. So I'm going to multiply both sides of this equation by negative 3 to turn that into negative 6. So let's see, negative 3 times 2 gives me negative 6x. Negative 3 times positive 3 gives me negative 9y equals negative 3 times 36. What is that? Negative 108. Negative 108. Now I can add the two equations together because my x's will eliminate. I have a positive 4 to negative 9, which gives me negative 5y equals 68 minus 108 is negative 40, which now means I can solve for y by dividing both sides by negative 5. So my negative 5's cancel. There's my y by itself. Equals negative 40 divided by negative 5 gives me positive 8. So now that I know that y is 8, where do I take it? All the way back up to the top. Put it in the y position. So if I do that, what am I going to have? 3x plus 2 times 8 equals 34. So now that means I can solve for this x. So I have 3x plus 16 equals 34. Subtract the 16. So 3x equals 18. And divide by 3. So x equals 6. Now remember, what are you finding when you're finding this x and the y? You're finding an ordered pair, right? You're finding a point where these two lines would cross if I graphed them, okay? So my ordered pair by x always comes first, so it'll be 6. And then my y is 8. Okay? Now, this leads in to, from here, we're going to have 3 equations instead of just 2. And in each equation, there's going to be an x, a y, and a z. So 3 equations and 3 variables.
So it's not going to be an ordered pair?
No, it's not going to be what an ordered pair. It's called, the answer will be what's called an ordered triple, because it's going to have X, Y, and Z. Okay, now 5 and 6 are just going to kind of lead us into getting ready to solve. Okay, on number 5, it's a multiple choice and it says choose the option that is an example of a linear equation in 3 variables. So 3 variables means you're going to have an X, a Y, and a Z. Linear means the X, the Y, and the Z are just X, Y, and Z. They're not squared or cubed or in denominators, right? That's what, if it's just the X, what does that make? It's going to make a line. So that's why you choose the one that doesn't have the X, Y, and Z in the denominator. Okay, let me show you what the options look like. The first one is so the reason it's not this is even though there's 3 variables, that's not linear because the X, Y, and Z are in denominators. Okay, the second option is X plus Y minus Z equals 1, which is the correct one, right? It's got 3 variables and nothing's happening with them. They're not squared or cubed or in denominators. The other 2 options don't have 3 variables. So this one is linear, but it's only got 2 variables. And that one too, it only has 1. Okay, so that's why this is an example of a linear equation with 3 different variables. Now, number 6 is what we were just saying. It doesn't, your answer when you're solving doesn't give you an ordered pair, it gives you an ordered triple. So the answer when you're solving these looks like this. It'll have 3 unknowns, okay? But this one again is multiple choice. So an example of what this would look like would be like that. Instead of an ordered pair, it'll just have 3 variables in it, or 3 numbers. Okay, now let's get to solving some of these. The first one, number 7, that I'm going to solve, I'm going to do it by hand. And then I'm going to do it in the calculator. And then after that, I'm just going to do it in the calculator. Go ahead. Yes. Yeah. All right. So this one looks like number 7. You've got X plus Y plus Z equals 2. You've got 2x plus 4y plus 2z equals 6. And you've got negative x plus 8y minus 3z equals 5. And we're still going to use that elimination method, just like when we were doing the 2 equations and 2 variables. So your goal is to be able to add 2 of the equations together and eliminate the x, the y, or the z. So look at the top one and the bottom one. If I add those together, my x's are going to eliminate, right? So that's what I'm going to do. That's what I'm going to start off doing. That's what I'm going to look for first, because if I don't have to mess with it and just add them together, then that's the easier part, right? So let's see. If I add the top one to the bottom one, x minus x, so those eliminate. What do you have for y's? 1 here, 8 here. So together you have 9 y's, 1z, and negative 3z gives me negative 2z. 2 and 5 gives me 7. So what you've done is you've eliminated your x's, and so now you only have y and z. Okay, I'm trying to get it down to where I just have one variable that I can solve for. So I eliminated my x's once. I need to eliminate them again. Okay, you just can't use the same exact equations. So what if I do this one and this one? To eliminate, you have to eliminate the same letter twice. Okay, so I've already eliminated my x's, so I'm going to eliminate my x's again, which means what does this x need to be to knock this one out? The opposite. -2, right? So that's what I need to multiply by. So let's see what that gives me. -2 times x gives me -2x. -2 times y gives me -2y. -2 times z gives me -2z equals 2 times -2 is -4. And then what am I going to add that to? Second equation, right? To knock out my x's again. So I'm just going to write that second equation under this. 2x plus 4y plus 2z equals 6. So add these together. Again, my x's eliminate, which is the reason we did it. -2y plus 4y is positive 2y. Now, this is very fortunate. This doesn't always happen. It's extremely rare. What's going to happen to your z's also? They're also going to cancel. Okay, that doesn't happen all the time, but my z's do cancel, which means I'm just left with -4 and +6, which is 2. Now, if your z's didn't cancel, you would still have y and z, right? Which you would put under here and then have to mess with them to eliminate another letter. But since this happened, what can I solve for? What can I figure out now? Y. So solve for y. So y equals 1. So I've solved for one of them. If I know what y is, can you go back to anywhere in the problem and find an equation that has a y and just one other variable? This one right here. If I know what y is, I can put it here. So y is 1. So I'll have 9 times 1 minus 2z equals 7. 9 times 1 is just 9. Minus 2z equals 7. Solving for this z, so subtract the 9 from both sides. So now I have -2z equals -2. And then divide both sides by that -2. So what does z equal? Well, it's also 1, right? Because -2 over -2 is 1. So now what do I know? I know y is 1. I know z is 1. So the only thing I don't know is x. But if I come all the way back up to the top, this is 1 and this is 1. Which means what's going to be my only unknown now? Right, this one right here. So let's plug 1's in for the y and the z. So I have x plus 1 equals 2. Add the ones together. So x plus 2 equals 2. And solve for x. So subtract the 2 from both sides. So x equals 0. So remember, when you put your answer in, it's that ordered triple with your x, your y, then your z. So your x comes first, which is 0. Your y is 0, and your z is 0. I mean 1. What did I say? 0, 1, and 1. It's systems of equations in 3 variables. So you've got 3 separate equations and 3 separate unknown variables. So this is how to work it out by hand. And actually this one was a lot more simple than they usually are, just because when I added these together, I automatically got it down to 1 variable. Again, that doesn't happen very much. So now I'm going to bring out over here. I'm going to show you how to do this in a calculator. Okay, what you're going to do is the original problem, you're going to use the matrix function in your calculator. Okay, and I'll show you where that is in a minute. You're going to input the coefficients of the left side of the equal sign into what's called a matrix. So my first equation is x plus y plus z, which means what are its coefficients? What are the numbers in front of the x, y, and z? Right, they're all ones in this case. The second row, coefficients are 2, 4, and 2. The third row's coefficients are -1, 8, and -3. So we're going to enter that into matrix A, and I'll show you how to do that in a second. Then you're going to make matrix B, which is the answer side. So what are those? 2, 6, and 5. Now, let's talk about what the order of a matrix is. Because when we get to the matrix function, that's the first thing it's going to ask you is, how big do I need to make your matrix? Which is your order, which the first part of it is the number of rows across, which this one has 1, 2, 3, by the number of columns, which is 1, 2, 3. So that matrix is going to be 3 by 3. This matrix, how many across? 1, 2, 3. But this time, how many columns? Just 1. Okay, so let's put this in our calculator. So what you're going to do is hit, to get to matrix, you'll hit the second button. And then that X to the -1 says matrix on top of it. So that's why you hit the second button first, because you want to get to that matrix option. So you're going to hit second matrix. So you should have this. I want to create 2 new matrices, these right here. So go over to edit. You're going to edit matrix A. So again, the first thing you're going to have to tell it where this cursor is that order. So how big is mine? So you need to enter 3 by 3. So 3, enter, 3, enter. And then enter your rows. So it's going to go across the top. So what do I need? Mine just is from the last problem I worked last class. So what do I need this to be? 1, 1, 1. So just 1, enter, 1, enter, 1, enter. My second row is 2, 4, 2. My last row is -1, 8, -3. Okay, now go back to matrix. So second matrix, go over to edit again, because now I want to create this matrix in my matrix B. So make sure you go down to matrix B. Oh, whoops, I just didn't do it. Down to B. Again, type in 3 by 1 this time, which is just going to tell the calculator what your matrix looks like. So 3 by 1, and then enter 2, 6, and 5. Now, I'm just going to quit. So just hit the second button, and then the button right next to it gets to quit. Because what you want to do is just go back to your regular blank screen. Now, the math part of this is you are going to do matrix A to the -1 power times matrix B. So second matrix. So second matrix. I stay on names this time, right? I'm not creating a new matrix. I don't need to go over to edit. I just hit enter because that puts that matrix on my home screen. Now hit that -1 button. So you have A to the -1, then you need matrix B. So second matrix, stay on names, but go down to B. Enter. So your home screen should look like that. Matrix A to the -1, matrix B, hit enter, and there's your answer. Same thing we got, right? 0, 1, and 1. And again, this function is very useful because like I said, even though solving that one did have a lot of steps, that's probably one of the easiest matrices and the easiest systems of equations in 3 variables that you're ever going to see. Okay, let's look at another one and just use the calculator. Okay, we're not going to do that. We'll do a couple more. But again, all the steps to the rest of these are exactly the same. You're just going to put them in your matrix function of your calculator. So let's do 9, and then we'll do 11. Go ahead.
So can we also, do we have to like input and store them every time, or can we just do alt and zoom and do that?
I don't know what that is. What do you mean?
Alt and zoom pulls up the you type in your row. And then you put enter. Okay.
Yeah, that'll do the same thing.
Okay, so if I have to do this, we're going to do this.
No. No. I mean, yes, it's fine for you to do that way. Okay, so let's look at number 9. I've got 3x plus 3y plus z. Equals 11. X minus 3y plus 2z equals -6. And 8x minus 2y plus 3z equals 9. Okay, now the most common mistakes on these are just entering the right numbers. Okay, if you don't get a good whole number answer for your x, y, and z, go back to the edit functions and look and make sure you just type stuff in right. So this one, matrix A, is going to be 3, 3, 1. 1, -3, 2. And 8, -2, 3. That'll be your matrix A. So let's put that in. So second matrix, over to edit. Enter. Oh, we know. What did I not? Yeah, that's it. Edit. 3 by 3 again, right? Across the top row, I have 3, 3, 1. Second row, I have 1, -3, 2. Bottom row, 8, -2, 3. Then go back to matrix. So second matrix, again, back over to edit, this time down to B. And what's B going to be? 11, -6, and 9. Right, it's still 3 by 1. 11, -6, 9. Again, I'm just going to quit now. I'll just go second to quit. Back to your home screen. So you're going to do matrix A to the -1, matrix B. So second matrix A. Hit the X to the -1 button. Second matrix down to B. Wow, I never did that before. But here's your X, Y, Z. So odd. Oh. Well, I've never done that before. No, that's not right. Hang on. What did I do wrong? I know, which is what it should be. A, the -1. Okay, I don't know what. I must have hit something wrong. Yeah, 2, 2, -1. Got it. Okay, I'm going to put one more up there, number 11, and let y'all try it in your calculator. That was number 9. 6R minus S plus T equals 6. 3R plus 2S. Yeah, I'm just not working every one because they're all exactly the same. Just putting it in your calculator. Yeah. This is 11. Okay, so on this one, we're going to use another way to get to the matrices that I just found or was told. I'm going to enter this by hitting the green alpha button, and then the zoom button. That takes you right straight to the matrix without going to the matrix. So you tell how many rows? How many columns? So my first one is 3 rows and 3 columns. So go over to 3, hit enter, go down to OK. And then enter your numbers. Instead of hitting enter after each number, we're going to hit the arrow key. So I need 6 alpha zoom. So 6, arrow to the right, -1, arrow to the right, +1. Then enter your second row, 3, arrow to the right, 2, arrow to the right, -3, arrow to the right. And your last row, 1, -3, 2. Arrow to the right to get out of that matrix, and then go ahead and hit your X to the -1 button again. And then you want the other matrix. So again, alpha, zoom. Now this time you want to tell it 3 rows, 1 column. So go down to the 1 and hit enter. So this is going to make a 3 by 1 down to OK. And then enter that second matrix, which will be 6, -3, -5. So 6, -3, -5. And then arrow to the right to get out of that second matrix. Okay, so this is the 2 matrices that you need, and they're already set up, ready to go. So just hit enter. And then there's your R, S, and T, 1, 6, and 6. Thank you for that input. Okay, so that's how you use the matrix function, or you can get to it by second matrix or alpha zoom. So let's go. Sorry, Celine. Into 3.6. All right. The first 2 problems in 3.6 are translating a sentence into what it would look like as a mathematical equation. Number one says the translation of the statement, the sum of three numbers is 50. I don't know what the three numbers are. I just know that the sum of them is 50. If I don't know what those numbers are, I'm just going to call them X, Y, and Z. So what's the sum mean you're doing? Adding, right? So X plus Y plus Z, there's the sum of three numbers. What are you going to put in the is spot? Equals 50. And that one's multiple choice. So you just choose the one that says X plus Y plus Z equals 50. All right, the second one is the same kind. It's a little trickier. The first number is, so the first number, we'll just call it X. And what do you always put in the is spot? Equals 50 more than the sum of the other two numbers. So what are the other two numbers going to be? Y and Z. The sum of them means to add them together. So if I do Y plus Z, if it's 50 more than this, I'll put plus 50. So 50 more than the other two, the sum of the other two numbers. Now, it is multiple choice. And on this, the Y and the Z are moved over here. The X, Y, and Z. So that way it looks like, you know, a system of equations kind of look. Okay, so if I'm moving the Y and Z over here, what am I needing to do? Cancel it here. Subtract the Y and Z there, which means I have to subtract the Y and Z here. Those cancel, there's 50. And the X, Y, and Z are now over here. So it's going to be what? X minus Y minus Z equals 50. So it'll be set up where all your variables are on one side and your constant is on the other side. So I just had to move all the letters to the left and the number on the right. They were up here. That's. You're good, you're good. Now, number 3 is talking about the angles of a triangle. Okay, and it expects that you already know that the 3 angles of a triangle, if I add them together, they're going to equal 180. Doesn't matter what the triangle looks like. If it's a triangle, the angles of it are going to add up to 180. Okay, doesn't tell you that. It just expects you to know it. So it says there's a triangle ABC. Let's see what information it gives me. It says the measure of angle B, so this angle, is 17 more than 3 times the measure of angle A. So I don't know what B is, but I can rename it using the letter A. What do you know about B? It's 17 more than 3 times A. So how can I write that? 3A plus 17, right? That's 17 more than 3 times the measure of angle A. It also tells me that angle C is 43 more than A. So what can I call C? If it's 43 more than A, good. So now look at what you have. You've renamed B and C how they relate to angle A. And what do these 3 angles add up to? 180. So this one is just angle A. If I add that to angle B, but what am I calling angle B? 3A plus 17. And add that to the C angle, which is A plus 43. So here's my 3 angles, A, B, and C. If I add those three angles together, what do they add up to? 180. So now look what you have. You've got an equation, and you only have one unknown variable, which is the A, which means isolate the A. Solve it for A. Now, I can clean up this left side a lot by combining like terms. Put all your A's together. There's 1, 4, 5 A's. I can also put, what else? The 17 and the 43 together. 60. So that's 60. So 5A plus 60 equals 180. Yeah, now you're just getting the A by itself. So subtract the 60 from both sides. So 5A equals 120. Now divided by 5. So A equals 120 divided by 5, which is 24. So I know that A is 24. Now that I know A, I know how B and C relate to A. So what are you putting in this A spot? 24. Right. So 3 times 24 plus 17. What does that give you? 89. 89 is angle B. Then how am I going to find angle C? What am I going to get? I'm going to put in the place of the A. 24 plus 43, which gives me 67. So again, it's going to give you a triangle A, B, and C. Then it's going to tell you statements about B and C, how they relate to A. So just rename them using how they relate to the A, and then add the three angles together and make them equal to 180. All right, let's look at number 4. There's only 5. All right, I'm going to come back over here to work number 4. I'm going to set up a matrix with these statements. Or set up a system of equations. Okay, it's going to give me 3 statements. The first statement says the sum of 3 numbers is 57. So how do you write that? Right. Equals 57. The second statement says the difference of the largest and the smallest is 44. How do you find the difference? What are you doing? Subtracting. Okay, so I'm just going to say this is the largest, this is the smallest. So the difference between those is 44, which would mean X minus Z equals 44. The last statement says the sum of the 2 smaller numbers is 17. So which one are the 2 smaller ones? So, and the sum of them, so Y plus Z is 17. So you had 3 statements that you translated into equations. Now I can use my matrix to solve for X, Y, and Z. Where there is no letters, what are you going to put in that part? Zeros. So let's go back to alpha. Zoom. Let's see, how many rows and columns is in my first matrix? 3 by 3 again. So change it to 3 by 3, hit OK. What's going to go across your top row? 1, 1, 1. Oh, sorry. So 1, 1, and 1 across the top row. And all kind of technical issues today. So 1 arrow, 1 arrow, 1 arrow. Your second row is 1, 0, -1. Your third row is 0, 1, 1. Arrow to get out. Then hit your -1 button. So X to the -1, and then alpha zoom again. Turn it to 3 by 1. Okay. And then enter your answer side. So 57, 44, 17. Enter. So there's your X, Y, and Z. Now, be careful, because what does the question say? When you're entering your answer, the first thing says the 3 numbers from the largest to the smallest. So make sure you do largest to smallest, which would be 40, 21, -4. All right, I think we have time to get this last one in. All right. This one talks about eating eggs, cupcakes, and pizza. So we're going to name these X, Y, and Z, or A, B, and C, or whatever you want to call it. The first sentence says, by eating 1 egg, 1 cupcake, and 1 slice of pizza, a child consumes 300 milligrams of cholesterol. So 1 of each of these. So you're going to have when she ate 1 of each of these, she consumed 300 milligrams of cholesterol. The second statement said, if the child eats 3 cupcakes, which would be 3Y, 4 slices of pizza, so plus 4Z, he or she takes in 85 milligrams of cholesterol. And the last statement says, by eating 2 eggs, so 2X, and 1 cupcake, so 1Y, the child consumes 500 milligrams of cholesterol. No, wait, 567 milligrams of cholesterol. So again, there's your matrix. Zeros go in the empty spots. So alpha, zoom, 3 by 3 again. So what's going to be across my top row? 1s. My second row, 0 for the X, 3 and 4. My last row, 2, 1, 0. And then arrow out of it. Hit your X to the -1 button. And then your second matrix. So alpha zoom. Turn it back into 3 by 1. Okay. And enter those numbers. So 385 and 567. And arrow out of it. And hit enter. So there's your X, your Y, your Z, which means the egg is 274, the cupcake is 19, and the pizza is 7 milligrams of cholesterol. Okay, so again, you're just translating the statements into equations, setting up the systems of equations, and then using the matrix function in your calculator.